Okay, today we're going to graph inequalities on a graphing grid. These notes were given on Monday, November the 15th. And so the first thing we need to look at are the symbols that go with graphing inequalities. Unlike graphing equations, you'll do the slope and the intercept the same way, but then your dots will be connected together with a different type of line depending on what the inequality symbol is, and then there's also shading that's required. So very quickly I'm going to go through the symbols with you. You're going to have a greater than symbol, less than symbol, greater than equal to, or less than equal to. Those are your options for symbols. And so what those are going to look like, what they will look like is a greater than symbol is going to have a dashed line when you connect your dots together. And then it will also have a shading on the problem, which would be shade above because it's a greater than symbol. So like if I had a picture, a small little picture of an X and Y axis, and I had a line that was graphed here with a dashed line, because this is a greater than symbol, all of the zone above the line would be shaded. That's where the shading goes. Your less than symbol is also going to be a dashed line. It will shade below the line. Your equal tos are both going to be a solid line, just like your normal, you're used to using in the normal equations you've been graphing. A greater than will have a shade above, and then the less than or equal to will have a solid line on it, and then the shade will be below. And so I'm not going to draw the rest of those, but I'll show you what they look like as we're going through the example problems. The biggest thing I tell the kids is to look and see if you've got an equal to symbol underneath your inequality symbol. That tells you you'll have a solid line, and if it doesn't, then you'll have dashed. All right, so going to our solutions, a solution to an inequality is basically a dot that falls on the line that you've graphed or in the shaded region. A point that lies on the line or in the shaded area of the graph. All right, so for example on A, I'm going to work through the examples of these. The practices will be problems that you can do on your own just to get more practice with them. They're very similar to the examples. There's one of the practices that I'm going to do just because it's different. First thing I've got here, I'm going to state my slope is 2 over 1 and my intercept is -3. This is just a carryover from our graphing chapters that we've done. So I'm going to go down to -3 and put my dot. I'll rise up 2 and over 1, and I can do that a couple of times to get some dots, or I can do down 2 and over 1 the other way. This will be connected together with a dashed line since it is just strictly a greater than symbol, and because it's a greater than symbol, your shade will be above the line. All right, example B, same thing. I've got a slope on this one of -1/2 and an intercept of +3. So I'm going to go up to 3 and put my dot. I'm going to go down 1 and over 2 for my slope, or up 1 and over 2 the other way. This again, I believe this one has an equal to on it. It's hard for me to tell on my screen, so I think it's an equal to. It's going to be a solid line, and since it's less than, it will be shaded below. Okay? Example C. We're going to have to solve this one first. This one's not in y equals form, so if I move my 4x, I'll get -2y is greater than -4x plus 6. If I divide everything by -2, that will finish the solving. However, I need to remember that when you divide by a negative on inequalities, your symbol changes directions. So instead of it being y is greater than, now it's going to be y is less than. -4 divided by -2 is +2, and I'll leave that over 1. And 6 divided by -2 would be -3. So my dot will be down here at -3 for my intercept. Then I would go up 2 and over 1 for the slope, or down 2 and over 1 the other way. It's just strictly less than, so I know I'll have a dashed line to connect my dots together. And then my shading now is going to be below, because since I have a less than symbol, all my shade would go below the line. Okay, example D, again I have to solve this one, but it's also going to ask me about a solution. We stated a minute ago that the solutions to an inequality were a dot that falls either on the line or in the shaded area. So for solving, if I add my 2x over here to the 12, I'm going to get negative 3y is less than or equal to 2x plus 12. If I divide to get rid of the negative 3 or remove it from the y, I'm going to get y is, now I'm going to have greater than or equal to, I divided by a negative, so my symbol had to change directions. There's no simplifying to do for 2/3, so I'll just leave it negative 2/3 x, and then 12 divided by negative 3 is negative 4. So I'm going down to negative 4 to put my dot, and then from that dot, I go down 2 and over 3 to the right, or up 2 and over 3 to the left. I'll connect those together this time with a solid line, and then my shade will now occur above because I've got a greater than equal to symbol, so my shading will be all above. Now, it's given me an ordered pair to check. It says, is negative 6, 0 a solution to this inequality? So if I graph a point on negative 6, 0, I'm going to notice that it's actually on the line or in the shaded area of the graph that I drew. So this one would be a yes. This would be a solution to our inequality because it is either on the line or in the shaded area. As you're working practice D, if you want extra practice later, I will let you know that 2, is not going to be a solution because it will not fall within the shaded area or on the line. All right, practice E, or example E and practice E. We'll do both of these because these are kind of the exception to the rule problems. If I do my solving here, I notice there's no x in the problem. I get y is greater than 2. Well, y is greater than 2 is going to be a 0 slope line here at 2. It will be dashed because there's no equal to symbol, and because it's greater than, it will be shaded above. Anytime you have an equation that's got y and a number, it's going to be a 0 slope line. Versus this one, where I only have an x, I would get x is greater than or equal to negative 4. This is a no slope line. No slope lines run parallel to the y-axis. They're vertical lines. They're straight up and down. This one's going to be a solid line because it's got an equal to on it, and the area that's greater than negative 4 would be all over here. So this side would be shaded. And then finally, being able to name the inequality from the graph. The first thing you want to look at, or I look at, is the intercept. And I notice that this equation is crossing the y-axis, or inequality is crossing the y-axis at 7. So I'm going to have my y. I'll have my plus 7 over here because it's that's the intercept. But I also remember, too, that it's a solid line shaded below. Below would be less than, solid line would give me an equal to. Now the only thing I have to come up with is the slope. Sometimes it's hard to see the slopes on these examples. It's just not super clear. Hopefully there will be dots on the problems that you'll see on your test. But if I go down 2 and over 1, down 2 and over 1, I'm kind of realizing that that's where the dots would be landing on the graph. So negative 2 over 1x, negative 2 over 1 would end up your slope on this one. Okay, let's do the next one the same way. I've got my y. I see my intercept is negative 4. I remember that this is a dashed line shaded above, which would give me a greater than. If I rise up one step and over 1, 2, 3, I end up on that line. If I try it again, I'll end up there again. So I believe my rise over run would be 1/3. And then, of course, you have the x there, and that's how you write an inequality from a picture.